I am taking two operands, inputs A and input B, and first I will take output sum, and I will take another output as difference, and output of multiplication I will take as output mul, and for division I will take divide, and initially I will take this, and for getting the output we are using data flow modeling, so I will use assign sum is equal to A plus B, and assign difference is equal to A minus B, and assign mult is equal to A star B, and for division we will use assign divide is equal to A divided by B. So we are using data flow modeling, in which we have seen addition, subtraction, multiplication and division. So these are arithmetic operation I am performing. So this is clear, right? Next, I will also perform one more operation, that is modulus operation. Output mod, I will take that as output mod, and I will perform modulus operation. Assign mod is equal to A percentage B, and ending this module. So for this, let me write the test bench, and we will see others in a while. So let me create a test bench file here. So if anyone having trouble writing some test bench, you can ask me now. I will try to help now. So this is the test bench. Yes. Yeah. So the file I have created for the test bench, and the design name is operator underscore ex. First I will instantiate it in my test bench. So operator underscore ex, which is our DUT. A and B are the inputs. Sum, difference, multiplication, division, modulus is our outputs. Am I right? Input A, B, sum, difference, multiplication, division and modulus are my outputs for now, and I will declare inputs as register type. Reg A comma B are my inputs. Coming to outputs, I will declare them as wires, difference, multiplication, division and modulus. So within an initial beginning block, so if we mention initial beginning block, then it will be a behavioral statement. It will come under behavioral statement. So in TB we will use initial beginning block, and I'm using the operator which is called concatenation operator. It will group the bits. So A comma B is equal to 0. So A will be equal to 0, B will be equal to 0 initially, and after some 10 time units, you can take any time units. After some delay, I am making A is equal to 1. Wait a minute, let me take some registers. Let's say this input is of 4 bit, and this B is also of 4 bit. Let us analyze like this, and sum is also of 4 bits, and difference is also of 4 bits. Let us leave this as 1 bit only. Now let's change here also. So reg 3 down to 0, that is 4 bits, and sum is 4 bits, so 3 down to 0. Sum and difference are 4 bits, and this multiplication, division and modulus are of 1 bit. Now let's see the yeah. Wait a minute. I'm waiting. So wire mal is already declared in line 27. Wait a minute. I'll declare them before this. Yeah. So A is equal to 0, B is equal to 0, and after some time unit delay, I am driving A is equal to 4 tick binary, not 4 tick. Observe here, A is 4 bit, but I am driving 3 tick binary 001, and B is also 4 bit, but I am driving 3 tick binary 1000. Now after some time unit, first I will display this dollar display using dollar display statement. Value of is percentage. I will represent it in percentage binary, and B is percentage B. So if I and I will use backslash n for uh, for an empty line, comma A comma B. So can anyone tell what is the value of A and B? Any guesses? And after one time unit, I'm displaying. Anyone? Just try. Like what will be the value of A and B? The value of, I'm printing sum is percentage B comma sum, and will also display the value of difference. Give it a try, guys. Wait a minute, why I am getting this error? Sorry, it should be dollar display. Dollar display. I'm displaying sum and difference, and I will also display this multiplication, division, and modulus also at the same time. So this dollar display. The value of multiplication is percentage B, and it is division. The value of division is percentage B, and modulus also I will print it. So I'm printing all these values and ending this initial beginning block and ending the module. And so I've given A is equal to 3 tick binary 001 and B is equal to 3 tick binary 100. I'm displaying the value of A and B, and after some time unit delay, I'm displaying sum, difference, multiplication, division, and modulus. And after some time unit delay again, I'm going to give the value of A as a 4 tick binary x001, and B is equal to 4 tick binary 001x. Now again I will display these values. After some time unit delay, say #1, I will display all these values. So this is how we write a test bench for a design. So is there any doubt in this design or test bench? Is this clear?
Explain once more again.
Yeah. So
Test bench.
yeah, what I'm doing is first I'm declaring inputs as inputs of the design are A and B. So in test bench I'm making them as red, and outputs of the design are sum difference, multiplication, division, mod. So I'm taking them as wire. We have discussed this right in the previous sessions, and I'm instantiating the design here. And within an initial beginning block, I'm initializing the inputs, that is A and B initial as 0. Then after some time unit delay, I'm giving A is equal to 3 tick binary 001 and B is equal to 3 tick binary 100. But my A and B are 4 bit, but I'm taking 3 bit. Then what is the value of A and B? That is what I'm asking. So after some time unit delay, I'm displaying all the outputs, and after some time unit delay again I'm driving different values, that is A is equal to 4 tick binary x 001 and B is equal to 4 tick binary 001x, and I'm displaying the values. So is this clear?
Yeah, clear.
Yeah. So in the first case, what is the output of A and B? Any guess? Okay, let me run the simulation and show you what happens if we are not giving 4 bits, but we have declared 4 bits, but we are not giving 4 bits. Then what happens? From this it will be clear. So this is an interview point also, like in written test they will confuse us with this type of manipulations, like they will declare 4 bit, but they will assign a 3 bit value. Then what will be the output? Like that, in that times we will be confused. let, let us wait. Output is getting. Let me open this. Here we can see, yeah, value of A is equal to 4 zeros ones and B is equal to 0100. Can you see this? Is this clear, right? So here what happening is, wait a minute, let me open the test bench again. So in the test bench, see this value, remember this value. Initially we are giving A is equal to 3 tick binary 001 and B is equal to 3 tick binary 100, and we are displaying the value of A and B, okay, 001 and 100. Then what we are getting at the output, here we can see at the output an extra 0 is being appended for A and B. So is this clear for everyone? We are giving only 001, but one more 0 is getting appended. Is this clear?
Yeah, yeah.
Yeah. So sum is nothing but addition of these two. That is, it will append 0 and it will add. This is the sum. And see the difference. Here 001 is equivalent to 1 and 0100 is equivalent to 4. 1 minus 4 is equal to minus 3. But we are getting 8 plus 4 12 plus 1 13. At the output we are getting 13. But we want the answer as minus 3. So can anyone tell what's happening here? Any guess? Okay, I will clear it. So here what happening is, wait a minute, let me zoom in. So when we perform subtraction in Verilog, if this first operand is greater than less than the second operand, then the Verilog performs subtraction in 2's complement form. So we are giving A as 1 and B as 3. So it will perform 2's complement on 3 And we already know from digital, right? A minus b is equal to a plus 2's complement of b. So it will perform 2's complement on b and it will add a and b. So that is what it is happening here. At the console we can see here we are giving a is equal to 1 and b is equal to 4. Our answer should be 1 minus 4, that is equal to minus 3, but we are getting 8 plus 4 12 plus 1 13. Basically it is performing 2's complement on this 4. 2's complement of 4 is nothing but wait a minute, let me calculate 2's complement of 4. So it will be equal to 100. So 2's complement of 4 is equal to 9. So it will perform 2's complement, sorry, 100. So 2's complement of 4 is 12. So it will 2's complement of 4 is nothing but 12. So 12 plus 1, that is equal to 13. So is this clear for everyone? What's happening in this difference operation, subtraction operation? Is there any doubt in this?
Yeah, clear, clear, clear.
Yeah. And for multiplication it is straightforward, but I am taking only one bit, so it is taking only the LSB. And for division also it is taking only the LSB. If I take 4 bits, then we will get the full answer. And for modulus operation, here it is 1 and this is 4. So 1 divided by 4, we will get a remainder of 1. So modulus operator basically remains gives us the retains the remainder. And this is the first set of output for the driven inputs in the test bench. So up to here we have got the inputs and outputs. So this is what we are displaying, and this is the second case. So here we are driving a is equal to 4 tick binary x001 and b is equal to 4 tick binary 001x, and we are displaying the value of a and b. So at the output, what happens? Here we are getting a is equal to x001 and b is equal to 001x. And if we are trying to display sum, we are getting whole unknown. Since addition operation cannot be done between two unknown quantities, so we are getting total unknown. So don't if it don't assume that x plus 0 is equal to x and 0 plus 0 0. So the output will be x0 0 x0 1 x. So don't get confused. So addition operation between any two quantities, if one bit is also unknown, then the whole result will be unknown. So this should be remembered. And the difference is also same. If any one of the bit is unknown, then the whole output will be unknown. And followed by multiplication also, if we take 4 bits, then we will get 4 unknowns. For division also same, and we will not get any modulus also. So this is what, if we take the inputs as x00 and 001x. So is this clear for everyone? Any doubts? If it is clear, then we can move forward. Can anyone tell now what is the output? What is the value of A and B? So this is also a very important point where we get confused when A is equal to 4 tick binary x01 and B is equal to 4 tick binary 01x. Then what is the value of A and B? So can anyone? Let me run this. So at the output we can see x is being appended. I'm giving in TB A is equal to 4 tick binary x01. I'm giving only 3 values, but I'm mentioning 4 tick binary x01. So here x is being appended here. We can see at the output A is equal to x01. So when we give 4 tick binary, when we mention the size as 4, but we are only giving 3 values, then the MSB will be appended. Here we can see I am giving only 0, 1, x, but I am mentioning the size of the number as 4. Here we can see that I am mentioning the size of the number as 4, but I am giving number of values as 3. So what happens is the simulator will append the MSB 0. But if I give the size as not here, if I give size here as 3, then see what happens. So the first case is I have given the size as 4, but I am giving the number of digits as 3 only. So the MSB is being appended. Now I am giving the size as 3 and the numbers are also 3. Then let's see what's being appended here. So here we can see the 0 is being appended. So this is a point where most of the people get confused. This is a very important point. So what happens here is if we are giving size as 3 and the numbers also number of digits also 3, then 0 will be appended. But if we are giving size as 4 but the number of digits less than the size, then the MSB will be appended. So this is the difference, we should be careful. So is this clear, right, for everyone? Is it confusing? Hello, can anyone confirm me? Is this clear or shall I explain?
Yeah, clear.
Okay, so that's why I mentioned this is the important session. So many times we get confused in this points. So please remember this points and coming to wait a minute. And we have logical operators next. Wait a minute. Operators here. And I will take another assign for logical operators or underscore out. I will perform logical OR operation and I will take here output or underscore out or underscore out. For logical OR, the symbol is double out. This symbol A or B. And for logical AND, it is A double ampersand B. I will mention the output here and underscore out. So here we will also get one important point. Yeah. So these two operations I am performing now in my TB. So in my TB, first of all, let me add this outputs also, where or underscore out and underscore out are my outputs, and let me add in the instance also or underscore out and underscore out. So these are my outputs or underscore out and underscore out, and let me display these values so that you can see what happening here. Dollar display value of or underscore out is percentage %b. Oh, let me take that variables as 4-bit or underscore out and this is and underscore out, and underscore out. Let me copy this and paste it over here. Yeah. Uh, Let me take a 4-bit so that we can analyze all the bits. 3 down to 0, or underscore out and underscore out. Whether I'm getting any error? No. Let me take here also output 3 down to 0 or underscore out and 3 down to 0 and underscore out. Yeah. So let me run this. Yeah. Let us check in the console. Where is the console? Yeah. So the output of the logical operators. Wait a minute. Where is this operators? This is a test bench and underscore out. Yeah. Sorry. The output of this logical operators is a single bit only, where it will be either 0 or 1, so no need of taking 4 bits. Remember this, the logical operators, we will get only 1 bit. It will be either true or false, or it will be in an unknown state. Let me relaunch it again. Yeah. Yeah. Here A is equal to 0001, B is equal to 0100. So or underscore out is equal to 1. So basically this logical or operation will perform. So in this logical or operation, if any of the input is high, then the output is high. If any one of the input is high, then the output will be high. And in case of logical and, the both the input should be high. If we take the first input as all zeros, then this logical and will be equal to 0. It is basically that and on or operations, but here it will be a single bit. It will be either 1 or 0. And coming to this, when a is equal to XX01 and b is equal to 001x, we can see here the logical and is equal to 1 and logical or is also equal to 1. So here we can conclude that if in a number, if any one of the digit is equal to high, here we can see we have a digit 1, and in this number we have a digit 1. So logical or will be equal to 1. Whether it we may contain unknown or anything, but we have some logic 0 or we are having some logic 1. So at least we are having some logic, so we are getting logical or as 1, and in case of and also we are getting 1. So what happens if we make all the digits as unknown, and let's see the output. Wait a minute, I will change the tick binary unknown, and let me run this. Yeah, in the console we can see the value of A is fully unknown and B is 001x. So at the output OR is getting 1, because here in the second number we are having some logic high value, but the value of AND is unknown. Since the A is completely unknown. So this is the logical operation. So is this clear for everyone? Is there any doubt?